A pump can fill a pool in 10 hours. Another pump can fill the same pool in 15 hours. How long will it take both pumps to fill the pool if they work together? So, pause this video, work this problem out, and comment your answer in the comment section down below. And also, kindly, as you do that, kindly subscribe to this channel. It's completely free of charge. Thank you. Let's continue. So we have a pump can fill a pool in 10 hours. Then another pump can fill the same pool in 15 hours. How long will it take both pumps to fill the pool if they work together? Now, since if you read the question and understand it, you should be smart enough to realize that if one pump can fill this pool in 10 hours and the other one can fill it in 15 hours, that means if they work together, the total time that they will have taken will be less than the one which had the least time. So it will be less than 10 hours. That is just logic. So if you work out your problem and realize that your answer is above 10 hours, then there could be a problem somewhere. You need to go back to your steps that you used and try and figure out where the problem came from, because logically it cannot be above 10 hours if just one pump can use 10 hours. So this means that when solving word problems, you should use your common sense to at least establish what is possible and what is not possible. Now you can consider this equation as a general formula to solve work problems, which is 1 over together, that is if they work together, is equals to 1 over the first part of the job plus 1 over the second part or the second party. So that is if there are two. For example, there are two people working together or there are two machines working together to complete a given job, you can use this formula. If there are three, say people or three machines or something like that, it can be 1 over together is equals to 1 over the first person or the first machine plus 1 over the second machine plus 1 over the third machine. So if there are more, you keep on adding the number of people or the number of machines or whatever that is working together to complete a specific task. So you can always use this formula to calculate the total work done. So the job altogether is represented by 1. So 1 over P1 means the rate that it takes P1 to do the job. 1 over P2 means the rate it takes P2 to do the job. 1 over P3 means the rate it takes P3 to do the job in order to complete the job, which is 1 equals to 1. So 1 is the sample space or the total outcome. So in our case, pump 1 takes 10 hours. Pump 2 takes 15 hours. Now let x be the time it takes when both pumps work together. The total time it will take when both pumps work together. So we've said we can say 1 over together, or the total time, which is x, is equals to 1 over the first pump, which is 10 hours, plus 1 over the second pump, which is 15 hours. So if you can remember this, then you'll be able to use it for most algebra work problems. So let's solve this. So here, the lowest common denominator would be, so we have x, 10 and 15. What is the lowest common denominator here? And divide by 10 here, it remains x. This is Now you divide by 5, sorry. By 5, this is x, this is 2, and this is 3. Divide by 2, here we have x, 1, 3. Divide by 3, we have x, 1, 1. And divide by x, we have 1, 1, 1. So you multiply these, we shall have 5 times 2 times 3 times x. So 5 times 2 is 10. 10 times 3 is 30. 30 times x, we have 30x. So 30x is the lowest common denominator. So we multiply the lowest common denominator by the whole expression. So this times 30x. When you multiply this times 30x, this will become 30x over x being equals to this times 30x becomes 30x over 10. Then this times 30x becomes 30x over 15. So this over x, the x cancels. This cancels with this, we are left with 3x. And 15 is divisible, goes into 30 2 times. So we have here 30 being equals to 3 times x is 3x plus 2x here. So 30 is equals to 3 plus 2 is 5x. Divide both sides by 5. So here 30 goes into 5 goes into 30 6 times. So x is equals to 6 hours. So it takes both pumps 6 hours to finish the job or to fill the pool. We could have done it this other way. Let x be the number of hours it takes both pumps to fill the pool. Now remember, the sample space or the total outcome should be 1. So that means for pump 1, remember the total time we've said is x. So out of x hours, when pump 1 is using 15 hours. So out of x hours, pump 1 is using 10. Then plus out of x hours, pump 2 is using 15 hours. These, when they work together, should be equals to the total time, which is 1, or the total sample space, which is 1. So implying that out of x hours, pump 1 takes 10, which gives x out of 10. Out of x hours, pump 2 takes 15 hours at each point in time. So, which means x out of 15. And all together, they must complete that task to give 1. So, we come up with this. Remember, 1 represents the total outcome or the sample space. So, let us work out this. Now here, the lowest common denominator, this is the same as over 1. So 10 and 15. When you divide by 5, here you get 2 and here you get 3. Divide by 2, you get 1 here and 3 here. Divide by 3, 1, 1. So 5 times 2 times 3. 5 times 2 is 10. 10 times 3 is 30. So you multiply the whole expression by the lowest common denominator, which is 30. So this will become 30x over 10 plus 30x over 15 being equals to, this times 1 is 30. So this is divisible by this. Here you get that 15 goes into 30 2 times. So we are left with 3x plus 2x being equals to 30. 3 plus 2 is 5, so 5x is equals to 30. Divide both sides by 5, and therefore x is equals to, this gives us 6. So therefore, both pumps take 6 hours to fill the pool if they work together. So that's how you deal with work problems. Thank you so much for watching. Kindly subscribe to this channel if you haven't already. Like this video, comment and share with your friends on different platforms. Thank you so much. Let's meet in the next video. Bye.